Hi, boys and girls. This is the last chapter, or the last lesson in Chapter 7. I just want to remind you, make sure that you finish your Chapter 7 performance task and all of your menu items for the end of the week. I think you'll find Chapter 7.9 pretty quick. I only have 8 slides on here to go through, so hopefully you'll have enough time to work on the other things you need to do today. Chapter 7.9 is identifying equivalent expressions. Yesterday's lesson, 7.8, was generating equivalent expressions, where we had to write them ourselves. Today we're going to identify or choose them. So I can identify equivalent algebraic expression as our objective. What you'll notice is you'll be given 2 algebraic expressions. Oops, sorry, I jumped ahead a little bit. And then you're going to have to see if they're equal or not. But first, here is a try it problem. Pause the video and try a warm-up from yesterday. You're going to just write an equivalent expression using the distributive property. Go ahead and try that now. Okay, there are a couple ways you could have done this. First example that you could have done is you could have said an equivalent expression is 7 times 2x. That's a times x in the middle there. Minus 7 times, 7 times 4. That's one way you could have done it. Another way, you could have done 7 times 2x is 14x, minus 7 times 4, which is 28. Both of these are perfectly acceptable answers. Both are equivalent expressions. So, hopefully you got that one right. Let's go ahead and move on to tonight's lesson. Example 1. Now, these instructions are not going to change for the whole lesson. Just write down the instructions one time, and then you can just write the examples for the rest of the time, okay? So example 1, determine whether the 2 expressions are equivalent. We have 2 expressions here. 1, 10t times 4, and 2, 14t. Are they equivalent? Are these equal expressions? I'm going to show you 2 ways that you can solve these, and I don't care which way you do, but I want you to know how to do both ways. First way, using properties to decide whether they're equivalent. The first way is, if I have 10t times 4, I can rewrite this as 10 times t times 4. Now, if I choose to combine like terms at this point, this is the associative property. If I do 10 times 4, that gives me 40. Now I still have my times t. So now I have 40t. So take a look again how I did that. I'm just going to review it with you. I had 10t times 4. I rewrote it as 10 times t times 4. And then I rearranged them because of the commutative property. Moved them around a little bit. And I said, let's combine these terms. 10 times 4 is 40. Times t is 40t. Is this the same as our other expression, 14t? No, it's not. They are not the same. So our expressions are not equivalent. That's our answer. Not equivalent. They are not the same thing. Let me show you the other way you could have done this. Another way is if you chose some variable or some number to represent t. So it doesn't matter what number you choose as long as it's the same. What if I chose t equals 4? This is like the guess and check method. T equals 4. If I do t equals 4, then I have 10 times 4 times 4. That's 40 times 4 equals 160. Then the other guess and check method, say, well, let's see if we get 160 in our other expression. 14 times 4, because t equals 4. Just substituting in. Oh, I'm not sure what 14 times 4 is. Let me do it over here. Okay, 56. So we got 56 when t equals 4 on 14t, and we got 160 when t equals 4 on the first expression. So again, we get to the same answer, that these two expressions are not equivalent. I just want to tell you again that the two ways of doing this are you can use the properties like I did in the first way to rearrange until you have similar expressions that you can compare, or you can do guess and check, pick a variable, a number for your variable, put it into both expressions, and if you get the same answer, they're equivalent. If you get different answers, they are not equivalent. Here's another example. Determine if the two expressions are equivalent. Here's my first expression and my second expression. This time, I'm going to decide, I'm going to do guess and check on this one. If I say x equals 2 and y equals 3, I'm going to solve my first problem, substituting in my variables. These just came from my brain, I'm just guessing. So 7 times 3 plus x equals 2 plus 3 times 3. So this will be 9 plus 2 equals 11, and 7 times 3 equals 21. 21 plus 11 gives me 32. Let's try it over here. If 10 times y, right here, I'm going to substitute this in, 10 times 3 plus 2 gives me 30, and that gives me 2. Oh, look at that. We have the same answer on both expressions, meaning that these expressions are equivalent. How cool is that? So this is just another method. There are other methods to do it if you wanted to combine like terms. 7y plus 3y equals 10y plus x. It's another way you could do it. Feel free to stop that, watch it, come back to it. I'm sorry, I'm a little bit tired right now, and so I feel like I'm not explaining it very well. So if you need more explanation on it, you can raise your hand and ask me. Hopefully I won't be as tired. Okay? Let's give you another example. Okay, here's a chance for you to go ahead and try it. You have 7k plus 4 plus 2k. Ooh, I can easily see some like terms I could combine here. Is this expression equal to 4 plus 9k? Try it and let me know. Alright, when you tried this, I hope that you did the easy way, or the method where you simply combine like terms. 7k plus 2k is 9k. What I have left is plus 4. Does that, oops, I don't need to write down there, sorry. And then I also have 4 plus 9k. Are these equal expressions? Yeah, because we have just the commutative property. I can move 9k and 4k around, and they're still the same. So yes, these are equivalent. If I would have tried saying, let's make k equal 3, let's see if it works for both problems. 7 times 3 is 21, plus 4, plus 2 times 3 is 6. So I have 21 plus 4 is 25, plus 6 is 31. Let's try it over here. If k equals 3, I have 4 plus 9 times 3 is 27. 27 plus 4 is 31. Equivalent answers on my guess and check, so equivalent expressions. Try it on this one. Determine if these expressions are equivalent. 8p plus 0 and 8p times 0. Hopefully this one doesn't trick you. Okay. The property that you would use to quickly spot if these were equivalent or not would be your identity property. The identity property states that when I multiply, or when I add something by 0, I still have the same number. But in identity for multiplication, I have to multiply it by 1 to keep the same number. When I multiply it by 0, I get 0. So these expressions are not equivalent, because whatever I put in this second expression over here 8p times 0, I could have p equals 3068, but when I times it by 0, it's always going to be 0. And this number, say p was, let's say 2, 2 times 8 would be 16, 16 plus 0 would be 16. So this one will just depend on whatever my number is times 8, and this one will always be 0 because we're multiplying by 0. So these two are not equivalent. Okay, here's another example that I'm going to explain to you. We have 10m plus n and 10m plus n. So let's go ahead and break this down. I'm going to use the distributive property from yesterday. I'm going to say that's 10 times m plus 10 times n. Do you see what I did there? I multiplied out with the distributive property because we're using those properties today. And now I have 10m plus 10n. It looks very similar to my other expression over here. But there's a very significant difference. This is the same, but this is not. So these expressions are not equivalent because 10n is not the same thing as n. Let's try plugging a number in. If I have m equals, again, these just come from my mind for guess and check. Let's try 2 and n equals 3. I try to make them small because then it's easier math for me. If m equals 2, then I have 10 times 2 plus 10 times 3. That's 20 plus 30. That equals 50. Let's try it on this one. Keeping my same variables, 10m would be 10 times 2 plus n, which is just 3. That gives me 20 plus 3 and 23. My answers are different, thus my expressions are not equivalent. On your own here, you have 6a times 4 and 24a. This is the last problem for this chapter. So again, I told you that this entire lesson was pretty fast, but this is it for the chapter. So try this one on your own and then we're done. Okay, here it is. This is how I solved this. I said 6 times a times 4. Similar to a problem I did at the very beginning of this show, or this video. 6 times a, I'm going to combine my like terms of 6 and 4, which gives me 24. Oh, that was a weird looking 24. Sorry. Let's try that again. 24. And then I still have my a, so I have 24 times a, which I can rewrite as 24a, which matches my other expression, so these are equivalent. If you wanted to do the guess and check method, let's say a equals 3. Then I have 24 times 3. I'm going to do this side first. 24 times 3 gives me 72. If 24 times 3 over here, I have 6 times 3, which is 18 times 4. There, sorry, I'm kind of jumping all over the place. 18 times 4. 4 times 8 is 2. 4, 5, 6, 7. We got the same answer. They are equivalent expressions. Alright guys, hopefully that gave you some skills that you can test to identify equivalent expressions. Good practice. That's the end of chapter 7. Make sure you get all of your work done by the end of Thursday so that you're ready for Friday. Thanks so much. Have a great night.